Hello. We are trying to predict the energy output of a combined cycle power plant. Energy output is a continuous numeric value, so this is a regression type of problem. The features that we have here are temperature, ambient pressure, relative humidity, exhaust vacuum. All the features seem to be relevant, so we will use all of them. The data set that we have is fairly small at less than 10,000 rows, so we can use traditional machine learning algorithms. Linear regression and random forest is what I'm going to be using. I'm using Python since I'm fairly familiar with Python coding. For comparison of the two models, I've split the data 80/20 for training and testing. For model validation and comparison, I've used k-fold cross validation to make full use of the training data. I've used five folds. For the purpose of model evaluation and comparison of the models, I've used RMSE and R square output metrics. RMSE is especially good in these kind of use cases because it penalizes large errors more heavily than metrics like MAE. R square is quite helpful with interpretability because it helps us understand what percentage of the energy output variance can be explained by the model. And to determine the best model, we will use RMSE. The model with the lowest RMSE will be chosen as the final model. So this is the data set, and the first four columns are the four features, and the final column is the energy output, which we are trying to predict. And this data set is split into 80/20 for training and testing, as I called out earlier. We are looking at the Python code base. I will talk about it at a high level. The two algorithms, linear regression and random forest regression, has been imported from sklearn. First, we load and split the combined cycle power plant data here, and then we define the five-fold cross validation. We have to define the models first before we can actually use them. Linear regression and random forest have been defined here. Then I evaluate the models using cross validation. Once we have the best model, we train the best model on the full training data set. Finally, we evaluate the best model with the test data to find out the RMSE and R square values. And then we do a visualization to see how good the model is performing. I'll execute the program now. As we can see here, for the linear regression model, the average RMSE is 4.57, and for random forest, the average RMSE is 3.46. Obviously, random forest is better performing than linear regression. So we have chosen random forest as the final model, and we evaluate it on the test data set. We get these results. RMSE is at 3.25 and R square is 0.9637. R square meaning 96.37% of energy output variance can be explained by the model. So it's a pretty good output that we have. And the visualization that we got as an output, the red dotted line basically is the actual values on the test data set, and all the blue circle dots correspond to the predicted values. As we can see here, they are quite close to the red line, which again gives us confidence that the model is performing well. Model interpretation, as we saw earlier, we have compared two different models, linear regression and random forest regression. And as we saw earlier, we have chosen random forest as the best model. And the final evaluation on random forest yielded a RMSE of 3.25 and R square of 0.9637. And the plot basically showed us that yes, the predicted data is quite close to the actual data as seen in the test data set. Thank you.